Mosquitoes are the world's deadliest animals. Many mosquito species, called vectors, transfer diseases from person to person when they bite. The most well-known of these diseases is malaria, which was responsible for over 400,000 deaths in 2018, affecting 28 million people. Overall, most cases occur in sub-Saharan Africa, where, out of thousands of mosquitoes, 40 species are vectors for malaria. Pregnant women and young children are the most at risk of getting sick. But what if we could stop malaria before it starts?
The best way to prevent the spread of malaria is to control vector populations. The WHO recommends targeted interventions such as insecticides and bed nets. Unfortunately, mosquitoes are resilient animals. They adapt to our interventions and have become resistant to our insecticides.
In order to determine which intervention should be deployed where, health programs conduct vector surveillance. They conduct vector surveillance by collecting mosquito specimens, determining what kind of species they are, which is very difficult, and then once they have that species, it's able to inform and monitor existing targeted control interventions.
This process is done in the field by trained entomologists who visually identify specific characteristics on each mosquito in order to classify it. This process is only 50 to 66% accurate and can take a long time, up to 20 minutes per specimen.
Our solution is a durable, portable field tool that will allow workers to accurately determine a mosquito species within seconds. The solution consists of two parts. There is the optical tool as well as a mobile application. The optical tool consists of a camera, standardized lighting and optics at a very low cost, which will allow anybody to take a high quality resolution picture of a mosquito. Workers simply place the optical tool over top of the mosquito, then they go to the mobile application, press a button, and it takes a high-resolution photo. The high-resolution photo is sent over the cloud to our computer vision algorithm. The cloud-based algorithm will then return the species label, which is displayed on the screen.
Our tool will increase the accuracy of speciation to over 90% and expedite processing so decision makers have immediate access to data. This data will empower control programs to determine the best interventions for an area, increasing their overall effectiveness and preventing malaria cases.
Our tool aims to bring resources to the beginning of the malaria intervention chain. Malaria is not just a health problem. It affects the economic, educational, and cultural outlook of a country. Our goal is to empower health systems to prevent malaria cases before they happen.